Hi all! Today's lesson is going to be on chapter 10.2, which is independent and dependent events. Grab your journals and we are starting at the top of page 288. The first thing that we need to talk about are independent and dependent events. So this says that two events are independent when the occurrence of one event does not affect the occurrence of the other. So an example of that, here we go, not is the important word there. The example of that would be if I draw one card from a deck of cards and then I spin a spinner. Doesn't matter which card I drew, it's not going to affect what I spin on the spinner. Okay. The other hand, though, we have two events are dependent when the occurrence of one event does affect the occurrence of the other event. Okay, so here a key word is does. So if I am going to draw two cards from a deck without replacement, so let's say I want to draw an ace and a king. So my probability of drawing an ace is 4 out of 52, but if I keep that ace out, my probability of drawing a king becomes 4 out of 51 because I withdrew a card. Okay, so we're going to look at some examples of those. Looking at the extra practice, the first one we have is that you have 3 white golf balls and 2 yellow golf balls in a bag. You randomly select one golf ball to hit now and another golf ball to place in your pocket. It says to use the sample space to determine whether randomly selecting a white golf ball first and then a white golf ball second are independent events. And the directions only want us to determine if it's independent and explain our reasoning. So we could do the whole sample space thing, but let's think through this. So you're going to draw two golf balls out of this bag. So you have the first ball and we have the second ball. What is the probability of drawing a white ball out of this bag, like just from the beginning? Well, we have a total of 5 balls in the bag. So if I want to draw a white one out, the probability would be 3 out of 5. That's for the first one. Assume you draw a white ball out. So now there are actually 2 white balls and 2 yellow balls left in the bag. And we want the second ball to be white also. Well, now there's only 2 white balls left, but there's a total of 4. So the fact that we drew a white ball out to begin with, or just the fact that we drew a ball out to begin with, it doesn't matter whether it's white or yellow, affected this probability. This probability is no longer 3 out of 5 or even 2 out of 5. Okay, it changed because you did not have 5 balls still in that bag. So this is what we would call a dependent event. And you would say because the probability of one affected the probability of the other. And hopefully you can read that. It says because the probability of one affected the probability of the other. Okay, up next we have your friend writes a phone number down on a piece of paper, but the last 3 numbers get smudged after being in your pocket all day. You decide to randomly choose numbers for each of the 3 digits. So again, it says use a sample space. We're going to kind of bypass that part. So we have all the phone number except the last 3 digits. Okay, so in a phone number, you can use the digit from 0 to 9. So there's 10 options. So what's the probability, right, that you're going to pick this number correctly? Or what's the probability of what this number is? Well, it can be any one out of those 10 numbers. Now, let's say that number happens to be a 6. Does that affect the probability of this next digit? If this one is a 6, can this one not be a 6? No, this one can still be a 6. So its probability is still 1 out of 10 because it can be any of those numbers, even the number you already chose. And what about the next one? It still can be any one of those 10 numbers. So this is what we call an independent event because the probability of one does not affect the probability of the other. Does not. All right, so let's move on and see how we actually figure out like the probability of this phone number. If you have independent events, and remember that is when they do not affect each other, to find the probability of both things occurring, you are going to multiply the probabilities together. So the probability of A and the probability of B. So maybe this is, I want the probability, I'm going to roll a 6 on the dice, and I want the probability that I'm going to draw the King of Hearts from a deck of cards. They do not affect each other. I would find the probabilities of both of them independently and then multiply them together. Now let's look at the probability of dependent events. So the nice thing is you still mathematically do the same thing here. We're still going to just multiply the probabilities together. But you have to take into consideration that the probability of the second event is going to change. This bar in the middle is your conditional probability, which we talked about in 10.1. Actually, we talked about complementary, sorry. This bar in the middle means the probability of B, assuming A already happened. So for example, this goes back to when I was talking about I want to draw an ace and a king from a deck of cards. The probability of drawing an ace from a deck of cards is going to be 4 out of 52. I could reduce that. But if I then also want to draw the probability of drawing a king, well, assuming I already drew out an ace, I have 4 options to draw a king, but I now only have 51 cards and not 52 because I drew out an ace. So let's look at figuring out probabilities for independent and dependent events. So these problems you need to read kind of closely and see whether they say with replacement or without replacement. So you're going to try to guess a 3-letter password that uses the letters A, E, I, O, U, and Y. Letters can be used more than once, so the password could be like AAA or EEE. Find the probability that you pick the correct password, which is YOU. Okay, so if we look at that, I have three letters that I'm going to pick. What's the probability the first letter is U? Nope, hold on. What's the probability the first letter is Y? All right, so there's 6 letters, so the probability that the first letter is Y is 1 out of 6. Now, because you can use the letters more than once, all 6 letters are still in play. So what's the probability the next letter is O? Still 1 out of 6. Okay, and you still have all 6 letters in play. So what's the probability the last letter is a U? It's also 1 out of 6. So you're going to multiply those together. That gives you 1 over 212. You're welcome to leave your answer like that unless it says to put it either there's my decimal form, that's a 0.0046, or that is 0.46%. So I have a 0.46% chance of correctly guessing YOU if the letters are still in play. How that changes if the letters cannot be used more than once. So here we have the same letters, A, E, I, O, U, and Y, and the letters cannot be used more than once. So you cannot get AAA. So we want to find the probability of picking AIE. So again, I have 3 letters I'm trying to pick. What's the probability the first one is A? Well, there's 6 letters to pick from, so the probability is 1 out of 6. Okay, you're going to assume you pick A, so A is off the table. So what's the probability the second letter is I? That probability is only 1 out of 5 because A was off the table. So now we're assuming you picked I, and now I is off the table. What's the probability that the third letter is an E? It is 1 out of 4. You're going to multiply those together. That gives you 1 over 120. Divide it to turn it into a decimal. And then if you want to, you can multiply by 100, so 0.83% as a 0.5%. So notice your probability about doubled because of replacement. So the chances of you getting it correct doubled because every time you had fewer letters to pick from. All right, up last, we're going to answer some questions from this table. The table shows the number of male and female college students who play collegiate basketball and collegiate soccer in the United States in some year. Now, whenever I do one of these table problems, the first thing I usually do is I go around and I add up the numbers. So like I'll add the numbers going across, and I'll add the numbers in the columns going up and down. And that's just so that when I need a number, it's already there. So adding across on the first line, I get 69103. Adding across on the second line, I get 64525. And adding the columns, the first column gives me 73763, and the second column gives me 59865. And then I already have those numbers ready. So when I read A wants the probability that a randomly selected collegiate soccer player is female. So I'm only looking here at soccer players. And then so female, we have a favorable would be 36523 over total, which is 73763. So there's my favorable over total. That is 0.495, which is about 0.4, hold on, not a point in this one, which is 49.5%. So I have almost a 50% chance of selecting a female out of the soccer players. The next question, find the probability that a randomly selected male student is a collegiate basketball player. So now I'm looking across here at the males all the way across, and I want the male to be a basketball player. So favorable is going to be 31863 over total, which is 69103. Divide that out, you get 0.461, which is 46.1% chance that if I have all the males, I'm going to grab a basketball player. All right, that's what I have for you for this lesson. If you have questions, please let me know or attend one of our live sessions. Have a great day.